Hello, this is Peter from Educommando, and a warm welcome to our second STEAM lesson, the Teacher Edition. You can ask your class whether they still know what STEAM stands for. It stands for Science, Technology, Engineering, Art, and Math. I really hope that you and your class enjoyed that first lesson. Today we are going to learn how to use the breadboard. A breadboard is this part of your project board. Here you will mount the electronic components and connect them to your microcontroller. The breadboard can be divided in two different zones. One zone, on the outside of the board, is mainly used to connect the power supply. Here you can see the red and blue or black lines with a plus and a minus sign. The plus sign is red and the minus sign is either blue or black. In the world of electronics, it is a convention that red is used for the plus pole and black or sometimes blue for the minus pole. You cannot repeat enough with your students that it is important not to mix these two, as many electronic parts are polarized, which means that they must be connected to the minus and the plus correctly. Connect those components the wrong way around and you run the risk that they will be damaged or broken. So make sure your students always pay attention. The other zone is where the components are plugged into. The holes that follow this line in the width of the board are connected, while the holes in the length of the breadboard are not connected. This zone is also divided by a line. You could compare this to a valley that splits mountains. The connected holes stop at this valley and start again at the other side. Each hole can also be defined by a number and a letter. For instance, hole B5 or hole E16. A breadboard is very useful to run experiments, and that's exactly what we are going to do in today's lesson. You are going to build your first experiment with your class. As part of your class preparation, you will hand out to your students the following components from the starter kit: a red LED, a light-emitting diode, a resistor of 220 ohms, the resistor value reference card, 2 jumper cables, preferably a red and a black one, and the most important, the Dino figurine. If you have soldering mats like the blue one that I am using, put the components into these boxes or areas. It will help your students not to lose them right away. Now it's time to explain to your class what the goal is of today's project. The first goal is to become familiar with 2 electronic components. The second goal is to understand what an electronic circuit or diagram is. The third step is to connect our microcontroller to the computer because we will need to program it in order to switch on the LED. The red LED is the eye of this Dino. As a first step, you will explain what the 2 main components are. The LED is in fact a lamp. LED stands for light emitting diode. You will see it has 2 legs, a long leg and a slightly shorter leg. Remind your students about the polarity because the LED must be connected the correct way. The long leg is the positive side and the short leg is the negative side. Don't mix them up, or the poor LED will be broken in no time. LEDs come in different forms and colors. In our starter kit, there is a collection of LEDs in different colors. We will use the red one. An LED light is quite fragile and doesn't need a lot of power. That is why it needs to be protected from too strong an electrical current. And that protection is provided by this little component, a resistor. As the word already assumes, it resists or reduces the current into the LED so that your LED will not become damaged. A resistor's value is expressed in ohm. For our project, we will pick a resistor with a value of 220 ohms. In this lesson, we will not yet go into Ohm's law, which allows us to calculate the exact value of a resistor in a circuit. In this lesson, we will teach our class how to read the value of a resistor. Basically, there are three ways to know the value of a resistor. The first method is using the color code reference card to decipher the resistor's value. Each resistor has colored rings printed on it. The colors of the rings refer to a certain value. The second method is using a multimeter. Multimeters can measure the ohm value of a resistor by turning the dial to the correct measuring unit. The third method is using a component tester to check the ohm value. The advantage of a component tester is that it is capable of measuring many types of components. At this stage of the lesson, you can hand out a couple of random resistors and let the students figure out the value of these resistors using the different methods depending on their availability. Before the students will jump onto their project boards, use your blackboard or whiteboard to remind them what today's goal is. Namely, to make the LED blink like the eye of a ferocious dino. Explain to them by means of a simple circuit diagram what we will be building on the breadboard. We start from the power source. In our case, this will be the microcontroller that delivers 5 volt to the breadboard. Tell your class that this could also be a battery as an alternative source of power. From the plus side of the power source, we connect one leg of the resistor. Tell them that this square box is one of the standard symbols for a resistor. The other one is more of a zigzag symbol. The current goes through the resistor to the long leg, the positive leg of the LED. Show your students what the LED symbol is. From the negative leg of the LED, we complete the circuit and we finish at the negative side of the power source. We have drawn a full circle, hence the name circuit. For most of the students, this will be the first time that I see a circuit diagram, so take your time to explain the different steps and symbols. Ask them if they understood the concept of what they are about to build. And now is the time to show them how to build the project. You take the LED and once again note the polarity. The long leg is the positive side of the LED and add the resistor to that positive leg of the LED. Connect the resistor with the red jumper wire to one of the digital pins. For our lesson, we will choose pin number 10. Connect the negative side of the LED with a black wire to the ground pin on the microcontroller. On the Arduino, there are 3 ground pins. You can ask your students if they can find them. Now that the physical side of the project is done, it is time to go to the programming part. Let the students connect their microcontroller to the computer. Let them report back to you that there is a functioning connection. Remember the blinking lights and happy sounds from the previous lesson. Check the USB connection between the microcontroller and the computer if there are issues. If an issue persists, you may have to restart the computer. Let your students open their microcontroller programming interface called the Arduino IDE or Integrated Development Environment. Repeat that the IDE is split into 2 parts, called the void setup and the void loop. At the top of the program, you can create your own space where we add the name of our project and clearly indicate that this is also the space where we define our variables. Ask your students why you begin with 2 slashes. The 2 slashes mean that what follows is a comment and is not a part of the program. Here we write our first line of code. int let pin equals 10, semicolon. This command tells the microcontroller that wherever it encounters the name let pin in the program, it actually refers to the number 10. Why do we declare a variable? In programming, we work a lot with variables because it is easier to change them throughout the program. For instance, if we would decide that we want to change the pin from 10 to 12, we simply change it here. int let pin equals 12. And everywhere in the program, it is now changed automatically. This is a lot easier than to go into the actual program and change pin 10 to pin 12 everywhere where it is used. We will now put it back to 10. int is short for integer. An integer is a number without decimals. 10 is a number without decimals, hence we can declare it as an integer variable. This is a good moment to emphasize that almost all command lines of the Arduino IDE end with a semicolon. Most of the errors you will see with your students are because they forgot to end a command with a semicolon. The next step is to do a one-time setup of this digital pin. We do that in the void setup space of the program with the command pin mode. The setup area is the place where we put the one-off commands. Pin mode, between brackets, let pin, comma, output, in capital letters, close the brackets and end with a semicolon. The microcontroller now knows that it has to activate this particular pin, and it will be used as an output because we are attaching an LED to it. We will be sending something to it, and that something is power, in the form of a 5-volt current. The next step in the program will be written in the void loop. This is the place where the recurring program commands take place. Because we want to let the LED blink, go on and off, we have to instruct the microcontroller to either send power or stop sending power to this pin. We do that by using the command digital write parenthesis let pin comma high in capital letters, close the parenthesis, and end with semicolon. This tells the microcontroller to set the pin number 10, at 5 volts. Because we want the LED to blink, it has to turn off again after a period of time. From the previous lesson, we know that this period of time, or pause, can be achieved through the delay command. We first need to define the duration of that delay in milliseconds. Let's go back to the top of the program and write integer dt equals 1000, and again close with semicolon. In the void loop, we type delay and in between brackets the variable that we just declared, dt, and end with semicolon. Now that will turn the LED on. Ask your students what they think will happen if we run the program now. You can either ask them or show them by uploading the program. The LED will light up, but it will not switch off again. However, we want to make it blink, so we need to also program the time the LED is off. Switching the LED on required the command high. It is logical to use the command low to switch it off again. In the void loop space, we type digital write and in between brackets let pin, comma, low in capitals, and we close again with a semicolon. And we will be using the same delay command, so delay in between brackets dt. Ask your students if this should be okay. And yes, we think it is. So let's give it a try and upload the program to the microcontroller. It works. Check with the students whether it works for them also. If not, let them check the code in their small team whether they have not forgotten any of the semicolons or misspelled any of the commands. Make sure that the color of the commands changed. That is the sign that the code is recognized. Only assist the students when they are really at a loss. And since we are using the breadboard, make sure that they also check the connections between the components and the microcontroller. A loose wire or component that does not fit nicely is enough to sabotage their project. End the lesson by repeating that we learned some new code and learned about some electronic components. We know how to use the breadboard and we know how to draw a simple circuit. They are ready for some more complex projects, like the next one, where we let the LED slowly go on and off like a twinkling star. Before you wrap up this lesson, give your students a fun assignment on dinosaurs. For instance, ask them to look up the following information which they can present to the classroom at a later stage. When did the dinosaurs live? Can you find 5 different types of dinosaurs? How tall was the largest dinosaur? What does Jurassic mean, like in the movie Jurassic Park? And why did dinosaurs become extinct? I hope you and your students enjoyed this lesson, and we'll see each other in the next one. Lesson number 3, Twinkling Star. Bye-bye.